Hello everyone, I am Muba. I between at UWC East Africa, and I'm starting a YouTube channel to discover one of the most interesting mathematical theorems, which were set a price of $1 million to whoever can solve it. And we are talking about Riemann hypothesis. Let me introduce you to German mathematician Bernhard Riemann, whose contribution has led to a Riemann integral, which we study in calculus, Riemann geometry, which was the essential part for Einstein's theory of relativity, and of course Riemann hypothesis. Born in 1826 to a poor family, Raymond's parents were determined for Raymond to have a good quality of education, so they assigned for him a homeschool tutors. After several months, a remarkable things happened with Raymond. He started teaching his tutors mathematics. He started teaching the teachers mathematics, to be clear. His extraordinary talent will lead him to University of Göttingen, where his professor was one of the greatest mathematicians of the world, Carl Friedrich Gauss. Under Gauss, he started delving more into prime numbers, and because of that, he made his paper called one prime number less than a given magnitude. Yeah. He was invited in 1859. He was invited to Berlin Academy of Science to present his 8 pages of paper, which was very short. However, that echo of the paper remained for 165 years in the mind of mathematicians. That paper had created careers and destroyed careers of mathematicians. In his paper, he introduced complex functions, later called Riemann zeta functions. So what he was really trying to say in his paper is that all non-trivial zeros are lie on specific critical line in the complex function. It's really a hard topic for me to understand right now. However, throughout other episodes, we will break down and we will try to understand more about Riemann zeta function, which later brought us to the Riemann hypothesis. Riemann died at the age of 39, so he didn't really had time to prove his conjecture. So what are prime numbers? Prime numbers are one of the oldest topics in mathematical history. They are any numbers that can only divide by 1 and themselves. So 2, 3, 5, 7, 11, and so on. Other numbers are called complex numbers. Those complex numbers are built by the product of two other prime numbers, such as 21 was built by the product of 3 and 7, both prime numbers, and all other numbers work the same. So throughout the years, mathematician has developed a very strong intuition and had found many patterns in prime numbers. However, the question is, we don't need to find the pattern of the prime numbers, but the absence of it. What does it mean that when mathematicians had found those patterns, if they wanted to prove them, they needed to prove them for all infinite numbers, which is, of course, impossible. So what you need to do as a mathematician is to prove the absence of the pattern, that there is no pattern existed. That's what Reimann wanted to do. Just to give you an example, the biggest prime number is 2 to the power of 84,500,000, which is about 24 million digits long. That's how the biggest prime number was discovered, and that brings us to 2,000 years earlier to a Greek mathematician Euclid, who had discovered and proved that there are infinitely number of prime numbers. We will talk about Euclid and his elegant proof in other episodes, and we also talk about the prime theorem. So why are prime numbers so important? Why many mathematicians and other scientists are so obsessed with prime numbers? Prime numbers can be spotted in a lot of places. For example, in the nature, prime numbers are spotted in the life cycle of cicadas insects. They hibernate every 13 and 17 years to the surface to find a mate or to die. And why they chose these specific prime numbers to hibernate is that if, for example, they have chosen 12 years and the predator of them had hibernated every 3 years, it means that after each 12 year, there will be predator for them. So If they chose 13 and 17 years to hibernate, it means that for the predator, it will be incredibly hard to predict their life cycle. Prime numbers can also be found in cryptography. In our bank accounts, in the message that we send to each other, are also built by a big number, which was the product of two other big digit prime numbers. That big number, let's call it n, is publicly, everyone can see it. And if that number was about to break down by some person or by some computer, it will mean that they have access to your data. However, because of that, it was built by the big digit of prime numbers. It's nearly impossible both for humans and for computer to break down that number to the two big prime numbers. That's what makes it very secure, the data, because it was built by the big prime numbers. Other example is prime number in physics. A very interesting story is that in 1970, a physicist called Freeman Dyson was having tea in Princeton, and he heard two mathematicians talking about the prime numbers. So later he came to them and he said that, wait, it's very interesting because the formula that you are talking about, we are using it in the same way to predict the level of energy in atom. It kind of don't make a lot of sense. However, it's still very interesting because an abstract mathematical formula can be used to find a level of energy in atom. This is all for this episode. We will talk more about the Riemann hypothesis and other interesting stories in next episodes. So click follow and we will see you later.